Hi guys. Now in this video I'm going to talk about some properties of conductors in electric field which are actually very interesting. Right? So let's start with this question. So let's say there is some electric field. Right? There are these electric field lines and it doesn't have to be constant electric field. There's some electric field. Right? So there are a bunch of charges out here, right, which are causing some electric field distribution. Now there is let's say there is a piece of metal, right? There's a piece of metal, right? Now the question is, what will be the field? What will be the electric field inside the metal? Right? So you could take I've taken an irregular surface. You could take a ball or something, but I want to take a more generic case, right? Now, when we talk about electric field, I'm specifically in this video I'm talking about electrostatics. Okay, I'm talking about electrostatics. Right? Electrostatics, which basically means that I'm saying the charges have come to rest, right? So the charges are not moving. In electricity, a different topic, they will talk about movement of charges. Here I'm talking about charges have come to their final resting position. So now let us say we apply an electric field. What will happen? So there's a conductor. So by definition, what does the conductor have? It has free electrons, right? So there'll be some, let's say the field is in this direction. So what will happen? The free electrons would get attracted. They would come here, right? They would get pulled and then they would come to the surface. And then you have some negative charges here on this side. And as a result, the electrons have kind of moved from here. So you'll have some positive charges left on the other side. Right? So now what happens is, now if you look at the field inside, there will be two components to the field inside. So there will be two fields here, right? There will be one field, E1 vector I'm calling. This is the field, or let's call it E external. E external. This is the field caused by all the charges and everything outside. And there will be one electric field, E internal, which should be the electric field caused by these charges, right? By these charges. These charges, so this is a plus charge, so it would cause a field in this direction, and these negative charges also would add to it, so there would be a field in this direction. And now see, these external charges, their field is in this direction, and the internal charge of the field is in opposite direction. So these charges would keep moving, right, until these two fields, they are equal and opposite, and as a result, E external plus E internal will become equal to 0. How do you know that? Because if it was not 0, if there was a net field, what would happen to the charge? Charge would keep moving, right? But by definition, we are talking about electrostatics, right? Where charges have finally settled down. They have settled down. So it's not like you cannot have field inside. You can have, but in less than a millisecond, right? The charges would redistribute such that now the internal and external fields will cancel each other, right? And that is a condition for electrostatics. So in electrostatics, when the electrostatic conditions prevail, then and only under those circumstances, the field inside a conductor will always be 0, right? This is the very, very interesting property, right? So first observation I would make is that electric field inside a conductor, right? Conductor is 0, right, in electrostatics, okay. So this is one very interesting observation. Now, second observation, let me pose to you as a question, right? Let's say I have some let's say I have again a metallic conductor, let's say in this case a piece of metal, and I put some charge, right? So I managed somehow to put some charge onto it. So let's say there is some charge here, right? Now is it possible that there might be some charge sitting inside? Could there be an excess charge, right, in certain parts of inside the conductor? Once again, is it possible, right, that there might be some excess charge inside the conductor at certain points inside the conductor? Okay? And the answer is no. Okay. Even if you go and put charge, you can put a lot of charge, right? But again, under electrostatic condition, right, there cannot be any charge inside. Why is that? So let's say there was some charge here, there was some positive charge here, negative charge, doesn't matter, some charge here. What I could take a Gaussian surface around that charge, right? I could take a spherical or some Gaussian surface just around wherever there is some charge concentration, take a Gaussian surface, and if I apply Gauss's law to this Gaussian surface, what will we say? We will say that integral E dot ds, right, is equal to Q inside upon epsilon naught. What is Q inside? Q is the charge. Q inside is charge inside the Gaussian surface. So it is charge inside this surface, right? It doesn't have to be spherical. It can be any shape, right? Now, just now we concluded that in electrostatics, electric field is zero. So my E total, my electric field is going to be equal to 0, which means this quantity is 0. If this is always 0, which means the left side is 0, which means my Q inside also has to be equal to 0. Right? Very, very interesting, conclusion from here that first the electric field inside has to be 0, and therefore now the charge inside also has to be 0, which means if you put some charge on a conductor, right, it will always be on the surface. It cannot be inside the body of the conductor. Okay. Now if I keep kind of pushing this, right, and keep thinking, what are the other consequences of the fact that in conductors there cannot be any electrostatic field inside? Let me come up with another scenario, another question for you, right? So now let us say again there is some conductor and it is a hollow conductor, right? It has got cavity inside. So here this is solid, right? And this is hollow, right? Now let us say I put some charge Q inside. I put some charge Q, let us say plus Q, some charges inside. It need not be point charge, it can be it can be distributed charge as well, doesn't matter, right? Now what will happen if I put this charge here? Think, what will be the result of this whole, of my putting this plus Q charge inside? These conditions will still hold, right? Because this is always true for electrostatics, which means the electric field inside the conductor is going to be always 0 in the body of the conductor, right? So now let's just see, what is the implication of that. So now let's say if I take a Gaussian surface, just covering outside covering the inner surface, right? For this Gaussian, now we have an enclosed Gaussian surface. Now here if I apply my Gauss's, if I apply Gauss's law, what will you get? We will get, right, integral E dot ds, right, is equal to Q inside upon epsilon naught. But E at every point, E is 0. Why is it 0? Because this Gaussian surface is within the body of the metal, right? So my E is equal to 0, which means always 0, which means this left side is 0. So now I have 0 is equal to Q inside upon epsilon naught, which means Q inside is 0. But now seems kind of weird because we said there is a plus Q, right? So what happens? So how is it 0? It can be 0 only if this induces some negative charge here, right? It will induce some negative charge here, and as a result of this, right, the total charge is going to be 0, which means if there is plus Q inside, this negative charge should add up to minus Q. This negative charge will add up to minus Q, and minus Q and plus Q, now the total charge will cancel, it will be equal to 0. Now just the intuition behind it, when I put a plus charge, what will happen? It will create a field, it will start pulling the electrons inside. So now the electrons, some electrons would move from here, right? They'll move inside, and as a result, there will be a net deficit of electrons on outside. So you would have positive charge on the surface, right? You'll have positive charge on the surface, and you will have negative charge, this negative charge inside, right? And so now what happens is, outside some charge is induced, and inside the total charge inside the cavity and in the internal boundary of the cavity, in total it will add to 0. Right? So these are some very interesting, simple but still very interesting applications or other implications of the concept of electrostatics for in case of a conductor. Thank you.